Hello. Now we will start the chapter current electricity, and the first thing we will study in this chapter is the current. Current we define as I. So by definition, current is time rate of flow of charge. So if I'm having any conductor I'm having, and this need not to be a conductor because in case of conductor, it provides the path to flow. If it is a path, even a hypothetical path, and in that path, if delta Q charge crosses a cross-section area in delta T time. So if in this conductor delta Q charge passes through this cross-section area, and I'm talking about the net charge here, delta Q net charge passes through the cross-section area in delta T time. In that case, current I is defined as delta Q by delta T. That's how we define the current. Okay, so in this case, you can see if this time, delta T time is very small, if this delta T time is very small, meaning it tending towards the zero, so we can write this value as dq upon dt. So the current is defined as either delta Q by delta T or dq by dt, time rate of flow of charge. Now if you see, I've talked about the net charge. I'm talking about this delta Q, which is the net charge. What does it mean by that? The net charge means, let's say if there is a cross-section area, and in that cross-section area, let's say if Q1 charge is crossing this cross-section area from left to right, and Q2 charge is crossing this cross-section area from right to left. So this cross-section area is crossed by Q1 plus Q2 charge. But corresponding to Q1 plus Q2 charge, we will not get the current, because this current is corresponding to the net charge flow in one particular direction. So if the Q1 is more than Q2, in that case we can say that Q1 minus Q2 charge in this conductor, that Q1 minus of Q2 net charge is passing through the cross-section area in some delta T time. If this Q1 minus Q2 charge is passing through the cross-section area in delta T time, so for this case, current will be defined as Q1 minus Q2 upon delta T. It's not Q1 plus Q2. So the direction does matter. So what kind of charge? If it's not just that charges are crossing the cross-section area, it matters what charge is crossing from right to left or from left to right. So we talk about the net charge passing through the cross-section area in one particular direction. So if the charge is flowing in both the direction, in that case, we have to talk about the net charge. And one more thing here, when we're talking about the Q1 and Q2, we have to consider the sign as well. How the sign will be taken care of? Like, I'll give you an example. If this is a cross-section area, and let's say if plus Q1 charge, meaning this is the positive charge which is crossing. If positive Q1 charge is passing through the cross-section area from left to right, and positive Q2 charge is passing through the area from right to left. In that case, the net charge passing through the cross-section area will be Q1 minus Q2. Now take the second case. If the same cross-section area is there, and in that cross-section area, if plus Q1 charge is passing from left to right, but minus Q2 charge is passing from right to left. So if you remember, when we talk about the charges, and when we say the positive charge is moving from A to B, it can be said the same thing. If the positive charge is moving from A to B, it means the negative charge is also moving from B to A. If we're talking about any cross-section area, and if we say there is these 2 points are there, A and B, and if we are saying that from A to B, positive charge is moving, at the same time, in the same case, we can say the negative charge of same amount is moving from B to A. So if positive charge of Q is moving from A to B, it can be said that negative charge of the same value Q is moving from B to A. It's up to us to consider any one of this. So if somebody says that negative charge is moving, that negative charge, movement of negative charge can be replaced by the movement of positive charge, but in opposite direction. So if you talk about this case, the Q1 is moving from left to right and minus Q2 is moving from right to left. So this whole case I can replace with that Q1 is moving from left to right and plus of Q2 is also moving from left to right, and this plus of Q2 we are saying because of this minus Q2. Since minus Q2 is moving from right to left, so we are replacing this charge by the positive charge by changing the direction. So in this case you can see the Q1 plus Q2 charge, this Q net in this case will be that Q1 plus Q2 charge is moving from left to right. So when you talk about the movement of charge, there is a convention. When we talk about movement of charge, to get the current, we always consider the movement of positive charge particle. So if examiner is giving you the movement of negative charge particle, like in this case, that movement of negative charge particle you will be replacing by the movement of positive charge particle with the same amount of charge but in opposite direction, and then you will be calculating the net charge flow in that particular case. Okay, so this is how we define the current. Current is defined as the time rate of flow of charge, and when we talk about charge, the charge we have to take as positive charge. By convention we have to talk about the positive charge. Okay, and the direction of current is defined as the direction of movement of positive charge. That's why when there was a negative charge given to us, we replaced that movement of negative charge by the movement of positive charge, so that we can calculate the value of current as well as the direction of current as well. Because to calculate the current, we need the net movement of positive charge. If there is only a positive charge which is given to you, you will take the difference. Okay, if the negative charge is given to you, what you will do? First you will convert the negative charge into the positive charge, and then you calculate the net flow of charge, and corresponding to that we will calculate the current as well as the direction of current. Okay, so that's how we define the current. Thank you.